Greetings, students. This is Miss Harris again. Alright, so we're doing 4-2, Triangle Congruence by side, 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 and side, angle, side. That's what the SSS stand for. It's side, 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 not SSS. Anyways, and that is side, angle, side, not SAS. This is just a short abbreviation. But anyways, let's get on to it. Page 226, 4-2. Alright. So your objective. Prove triangles are congruent using the side, 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 and side, angle, side postulate. Essential question. How can you establish the side, 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 and side, angle, side triangle congruence criteria using properties of rigid motion? Alright, so on page 427, your first postulate. Can I move this over? Can I move it? Let me try to move it. I'm moving it. Okay. Either way, it's important. Alright, so postulate 4-1, side, side, side postulate. If the three sides of one triangle are congruent to the three sides of another triangle, then the two triangles are congruent. So on the last video, I told you guys, in order to prove that any polygon is congruent, all parts have to be congruent, all the angles and all the sides. But now with triangles, it doesn't have to be all the sides, okay? With triangles, you can only, if three parts are congruent by certain postulates, then we can prove the triangles are congruent without proving each part is congruent. So that first postulate is side, side, side. So basically, again, if all the sides of the triangle are congruent to each other, then the triangles are congruent. And remember these markings meaning they're congruent. One line, AB is congruent to DE. Two lines, BC is congruent to EF. Three lines, AC is congruent to DF. Therefore, triangle ABC is congruent to triangle DEF. Alright? So, as described in Chapter 1, a postulate is an accepted statement of fact. The side, side, side postulate is perhaps the most logical fact about triangles. It agrees with the notion that triangles are rigid figures. Their shape does not change until pressure on their sides forces them to break. This rigidity property is important to architects and engineers when they build things such as bicycle frames and steel bridges. See, architects and engineers, that's when you need math. Mr. and Mrs. When am I going to need this stuff? It's important for architects and engineers, and they make a lot of money. So anyways, alright. So problem 1. Oops. Yep. Alright, problem 1 on page 227. Identifying corresponding congruent sides. So these are my two triangles, LMN and NPL. So let's use the side, side, side postulate. So PN is congruent to LM. How do we know? Because the sides are congruent. You see that? They're marked. So that is given that they're congruent. Alright. And then also PL and NM. That's also given, or LP and NM. Whatever. It doesn't matter. LP and NM are also congruent because they're marked by 2. And then you have this line right here. Remember, that's the property I told you guys to look up on the last video. That is the reflexive property. Okay, if you have those two triangles, and you kind of split it together, they'll both still have that side. So that side, LN, is for both of those triangles. So LN, since it's the same line, LN is congruent to LN by the reflexive property. Alright, and since they're all congruent, we can prove that's 3 sides. Make sure you mark it. One thing I like to do is I like to put a, every time I label something, I put what it is. So this is a side, so I put S. Then this is another side, I put S. Then this is another side, I put S. So that tells you that is proven congruent by side, side, side. So LMN is congruent to NPL. Okay? So, go ahead and try this and see if you can prove that this triangle is congruent. Now, this is guided number 1 is just like the problem, so it shouldn't be any problem for you, okay? So again, I'll be looking for this tomorrow or whenever the next class is that you have me. So make sure you have it written down. Okay. All right. Postulate 4-2, page 228. You can also show relationships between a pair of corresponding sides and an included angle. So the included angle is the angle between the two sides. The word included refers to angles and the sides of a triangle as shown at right. So this is the side angle side postulate. So now this says if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the triangles are congruent. So this is a big part in geometry, so you want to see this a lot, okay? Let me see something. Okay. So anyways, so if you look here, the key part here is that the angle has to be in the middle. If the angle is not in the middle, it does not work. So there's no ASS postulate. There's no angle side sides. I'm not going to see the words. There's no ASS postulate. So again, the angle has to be in between the two sides in order for this to work. Alright, so AB is congruent to DE. It's marked here for you. You have your angles. They're also marked. Those are congruent. And then you have your sides, AC and DF. Those are marked by two lines, so those are congruent. So therefore, triangle ABC is congruent to triangle DEF. Alright? Sorry, I hope I'm not talking too fast. But yeah. So, problem 2, page 229. What other information do you need to prove that triangle DEF is congruent to triangle FGD? So let's first write down what we have. Alright, so we see that EF is congruent to DG, right? Right, y'all see that, the markings? So those are definitely congruent. Why? Because it's marked by those lines. So that's given to you. Then remember, here's this line again, reflexive property. You're going to see that again. You're going to see that a lot. DF is congruent to DF by the reflexive property. So we have a side and a side. I'm sorry, a side, one pair of sides congruent and another pair of sides congruent. What are we missing? An angle. And not just any angle, you need the angle between the two sides. So between EF and DF is angle EFD. You can't say F because F is this whole angle. Angle EFD, and between DG and DF is angle DGF. Alright, so we need to know if EFD is congruent to GDF. Once we know that, then we can prove it's congruent. If you don't know that, we can't prove it's congruent. Okay? So that is for side angle side. Alright, so if we were trying to prove that they're congruent by side, side, which angle would you need? I mean, what else would you need? Not angle. What else would you need? Think about it. Moving on. Alright. Move this. Move me down, move me down. Alright. So what information do you need to prove that triangle LEB is congruent to triangle BNL? So remember, write down everything you have. Don't forget your reflexive property and label it. If it's an angle, label it A. If it's a side, label it S. If it's, so you can see what you're missing. Alright? So try this. I'll check for it tomorrow. Alright, so page 229. So now we're going to use everything we learned from the side, and the side angle side to prove the triangles are congruent. It says, would you use side, or side angle side to prove the triangles are congruent? If there's not enough information to prove the triangles are congruent, write it not enough information. Alright, so plan. What should you look for first, sides or angles? So right here it says it's good to start with the sides, because if you have 3 pairs of congruent sides, you can use side. Alright, if you only have 2 pairs of congruent sides, remember it has to be the angle in between the 2 congruent sides. Alright, so let's try this. So let's look at A. Alright, so we have this side is congruent to this side by that marking. This side is congruent to that side by that marking. And then we have also an angle. So what is that? That's right! Side angle side. And you see the angle is the included angle. This angle is in between the 2 sides. Alright, so now let's look at B. We have this side and this side is congruent. This side and this side is congruent. And then these two angles are congruent. Does this one work? Do you guys like Dora? Do you see the angle in the middle? Anyways, this one does not work. Why not? Again, I'm doing a Dora pause. Okay, it doesn't work because the angle is not in between for this one. This angle is off to the side. It has to be in between the two sides, just like this one. So there's not enough information. You look at this one, you have 3 markings on the sides, and one has 1, another one has 2, and another one has 3. 3 sides are congruent. So D, this one, you see the 3 sides are marked again, so they can be congruent by side, 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 like here. But this is also a pair of what type of angles? I said it's never going away. Vertical angles, that's right. And since that angle is between the same 2 sides, it can also be proven by side angle side. So that one you can use 2. You can use 2. All right. So, yeah, that's it for that. So, guided number 3. So tell me what's the best way to prove this. Could you prove it by side, 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 or side angle side? Or do you need more information? Alright, so go ahead and try it, and we'll check it tomorrow. Alright, so we're basically done with this chapter, but what I want you to do is I want you to try to answer the essential question, and also write this in your notes. How can you prove 2 triangles are congruent without proving that all corresponding parts are congruent? So think about it, write it out, let me know tomorrow. Alright, so that is it. This has been your wonderful teacher, Ms. Harris. Thank you for your time. Thank you for doing your homework. So I will see you next class. Have a good day and a blessed night. Do your homework, your other homework for other classes. Don't watch TV all night or be on Facebook or whatever. Anyways, bye.